Welcome to our online class. This is Ma'am Teresa Tubal. Join me to enjoy mathematics. Let us explore about Fibonacci sequence. Let's go. So let us familiarize with Fibonacci. So this is the face of Fibonacci. So Fibonacci was a nickname which roughly means son of Bonacci. And what could be his real name? His real name was Leonardo Pisano Bugoglio, and he lived between 1170 and 1250 in Italy. And he also helped spread the use of Hindu system. So the Hindu system is 0, 1, 2, 3, 4, 5, and so on, in place of the Roman numerals. As you remember, the Roman numerals is I, X, L, C. That is the Roman numerals. How we discovered the Fibonacci sequence. If a pair of rabbits is placed in an enclosed area, how many rabbits will be born there? If we assume that every month, a pair of rabbits produces another pair, and that rabbits begin to bear young 2 months after their birth. So let us see how Fibonacci sequence discover by observing the rabbits. At the start, no rabbits are born, as the initial pair have not time to be pregnant and born. In the first month, one pair of rabbits is born. In the second month, another one pair of rabbits is born, and the other pair are not yet mature to bear young. In the third month, two pair of rabbits are born, while the other pair are not yet mature to bear young. In the fourth month, three pairs of rabbits are born, and the two pairs are not yet mature to bear young. In the fifth month, five pairs of rabbits are born, and three rabbits are not yet mature to bear young. So as you can see, in Fibonacci sequence, it is always 0, 1, 1, 2, 3, and 5. Fibonacci sequence is a series of numbers that where a number is the addition of the last two numbers starting with 0 and 1. So the Fibonacci sequence rule, f sub n is equal to f sub n minus 1 plus f sub n minus 2, where f sub n is the number of term and f sub n minus 1 is the previous term, and the f sub n minus 2 is the term before the previous. Fibonacci sequence series of numbers are 0, 1, 1, 2, 3, 5, 8, 13, 21, and 34. How to get those consecutive numbers? So as you can see, we may add 1 plus 0 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, 8 plus 5 is 13, 13 plus 8 is 21, 21 plus 13 is 34. What do you think is the next number after 34? So the rule, f sub n is equal to f sub n minus 1 plus f sub n minus 2. So that is f sub 11. If we count, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the unknown is f sub 11 is equal to 11 minus 1, that is f sub 10. 11 minus 2, 9, so f sub 9. So f sub 11 is equal to the previous. The unknown before the previous is 34. And before the previous is 21. So 34 plus 21, f sub 11 is equal to 55. So it means the next number after 34 is 55. In the given Fibonacci sequence series of numbers, what is the next number after 55? So the formula or the rule, f sub n is equal to f sub n minus 1 plus f sub n minus 2. So it means the unknown is f sub 12. So if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so f sub 12. So f sub n minus 1, that is the previous before the unknown. So that is 55. And the term before the previous, that is 34. So 55 plus 34, the answer is equal to 89. So the next number after 55 is 89. Question number 3. What is the next number after 89? So again, the formula f sub n is equal to f sub n minus 1 plus f sub n minus 2. So the unknown now is the 13. So if we get the value of the f sub 13, the previous before the unknown is 89, and then the term before the previous is 55. So 89 plus 55, the answer is equal to 144. So the next number after 89 is 144. In the given 13, 21, 34, and 55, what do you think is the next two terms? So the rule, f sub n is equal to f sub n minus 1 plus f sub n minus 2. So the unknown is the fifth term. So the fifth term is equal to f sub 4. This is the previous, and the term before the previous is 34. So that becomes f sub 5 is equal to 55 plus 34. So 55 plus 34, f sub 5 is equal to 89. How about the next after 89? So that is f sub 6. F sub 6 is equal to the previous f sub 5, and the term before the previous is f sub 4. So that is f sub 6 is equal to 89 plus 55. So 89 plus 55, the answer is equal to 144. Find the ninth term of the Fibonacci sequence 8, 13, 21, 34, and 55. So as you can see, the first term is 8, the second term 13, the third term is 13 plus 8, it is 21. 21 plus 13, the answer is 34. 34 plus 21, it is 55. So 55 plus 34, f sub 6 is 89. So 89 plus 55, f sub 7 is 144. So 144 plus 89, f sub 8 is 233. And then 233 plus 144, so the f sub 9 is equal to 377. So the ninth term of this given Fibonacci sequence, the answer is equal to 377. So let us see in the diagram the example of Fibonacci sequence. So 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, 8, 8 plus 5, 13, 13 plus 8, 21, 21 plus 13 is 34. So when we make square with those widths, we get a nice spiral. So these are the example of the spiral. Example of Fibonacci sequence is a stair. So pwedeng inaakit nyo lang yun o nakikita nyo sa paligid. Other Fibonacci sequence that you will see in the nature, like a snail. You can see also the Fibonacci sequence in the petals of the flowers. The petals of the flowers have 5, 8, and so on. We can also see the Fibonacci sequence in the sunflower, as you can see at the center of the sunflower. We can see also in the sunflower seeds some examples that we can see Fibonacci sequence. You can see the beauty of nature that have Fibonacci sequence. Fibonacci sequence is a series of numbers that where a number is the addition of the last two numbers starting with 0 and 1. Fibonacci sequence, in our rule, f sub n is equal to f sub n minus 1 plus f sub n minus 2, where f sub n is the number of term, f sub n minus 1 is the previous term, and f sub n minus 2 is the term before the previous. I hope you will also see the Fibonacci sequence everywhere. Enjoy learning mathematics. I'm Teresa Tubal. Thank you so much.